Okay, I think I said that previous one was the last video on this 18.5, but hey, can't always predict these things. So we saw in the last one that if an object is floating, then we have this situation where your displaced volume is equal to the density of the object divided by the density of the fluid multiplied by the volume of the object. And we saw that if the density of the object is the average mass density of the object is smaller than the mass density of the fluid, then it floats. It floats. Okay, that's what we saw here. Okay? So whenever it floats, no, that's not true. Whenever the mass density is smaller, it floats. But an object can still float when the density of the object is larger than the density of fluid, so long as the displaced volume of the fluid is large enough. Okay? Please make sure that you understand that. I'm just going to go back and show you. See if I can find this. Okay, here we go. Figure 18.2. Steel ships can float even though steel sinks. Okay? Remember, steel, the density of steel is much larger than the density of water, but you can make it float as long as you design the steel object so that it displaces sufficient amount of water so that the upward buoyancy force is large enough, is bigger than the downward gravitational force. Okay? So please make sure that you absorb that. Okay? By the way, you can always shoot me an email as well. Okay, where were we? Were we here? Okay. Okay, then what about sinking? An object will sink when the FB is smaller than FG. Obviously, right? And so the density of the fluid times the displaced volume of water or fluid equals what? Density of the object, average density, times the volume of the object. But what we're saying actually is that this is the buoyancy force on the left, must be smaller than the gravitational force. Okay? And obviously if it's sinking, then it means that the displaced fluid and the volume of the object is the same. Okay? So rho f is smaller than rho of the object. So the density of the fluid is smaller than the density of the object. For example, a little steel block inside water is just going to sink. Okay? But if you change that same steel block and it displaces a large enough amount of water, then the buoyancy force will be large enough to stop it from sinking. Okay, then finally, when the object's average mass density is equal to the mass density of the fluid, which is basically, if you just have a block or a cylinder of water inside water, okay, that has the same density, then we have neutral buoyancy. It can hang motionless anywhere in the fluid. Okay, I think that's good enough for now.